this video lecture. So we are going to talk about triangular numbers. By the way, I am Miss Melanie G. Garat. So in coming up with a triangle, so our objective now is to make use of this emoticon that will represent as length 1. So our objective is to come up with equilateral triangle, which means that all sides are equal. So if we want to come up now with a triangle with side 2, so we're going to use two emoticons here, but this is already counted as 1, so we just need to add one more emoticon. So we have two emoticons for each side of the triangle. So that's adding 1 and then plus 2 is equal to 3 objects. Now, if we're going to add another length, so we will make it 3 objects or 3 emoticons for each side of the triangle. Then we have to add 1 plus 2 plus 3 to come up now with the number of emoticons used to form this triangle. It is equal to 6. Now, if each side of the triangle is equal to 4, then it means that we're going to add 1 plus 2 plus 3 and plus 4 to come up now with triangle that forms equilateral triangle with length 4, and the total number of objects used is equal to 10. So did you see a pattern in constructing these triangles? This is actually called a triangular number. 1, 3, 6, and 10 are triangular numbers. So if we're going to continue the process, then it means that we just need to add plus 5, plus 6, plus 7, and so on to the original or to the previous number of objects needed to form the triangle. Okay, now to explain further about the triangular number, have you heard of the famous story of the famous mathematician named Carl Friedrich Gauss or Carl Gauss? So let me tell you the story. So this is about a classroom setup wherein the teacher of Gauss, asked them to find the sum of all the numbers from 1 to 100. So immediately, Gauss stood up to tell the answer that the answer is 5050. So the teacher let him explain how he obtained the number 5050. So instead of showing the teacher that he added 1 plus 2 plus 3 plus 4, what he did was to explain now the pattern, or rather to come up now with equations how to determine the sum of consecutive numbers. So this is how he explained it. So let us show this using whiteboard. So let's have 1 plus 2 plus 3 until to the last number. So we have, for example, here 98, 99, and 100. Now, if we're going to consider the sum of the first and the last number, that is 1 plus 100, this is equal to 101. If we will also add 2 plus 99, the result is also 101. 3 plus 98, the answer is, of course, 101. So 4 plus 97 and so on, the result will always equal to 101. But how many 101s are there from 1 to 100? If we're going to continue adding the first and the last, the second and the second to the last, or the corresponding numbers in the first and second by pairing them. So of course this is 100. So if you notice, we are just pairing it with the last number. So how many pairs are there in 100? It is 50. It is actually simply dividing 100 because we are pairing it. 100 over 2 is equal to 50. Now, to answer the question, what is the sum from 1 to 100? What Carl Gauss did was to multiply 50 times 101 is equal to 5,050. So if we are going to change the values of the last number into n, so 1 plus 2 plus 3 until this is n, and 99 is n minus 1, plus 98 is n minus 2. What is now the general equation or the general formula to come up now with the formula of our triangular number? So this is 1. Let's replace 100 to n. So it is 1 plus n. 2 plus 99 is simply 2 plus n minus 1. Of course, here you will still get 1 plus n or n plus 1. So which means that we can replace 1 plus 100 into n plus 1 or 1 plus n. And then to count for the number of pairs, as what we did in this example, it is 100 over 2, so we will just compute n over 2. So the number of objects now to get them to form an equilateral triangle is n over 2 multiplied by n plus 1. So this is the formula of our triangular number. So let's go back to our slide. Okay, so it is n multiplied by n plus 1 all over 2. So my reference, so it is posted in our screen. Okay, that is all for today. Thank you for listening.